Okay, hi AP Chemistry. Some of y'all joined in on the Zoom video and some of y'all did not. And so I realized on the Zoom video we went farther than we did in the notes. So I'm picking up where I left off with my last YouTube video, which I explained hydrogen bonding and helium bonding. So then we're gonna jump in with lithium now. So we're on page 8 of your notes. And on the previous videos, I drew hydrogen, I drew helium, and I explained how to calculate bond order. So we're gonna do the same thing with lithium. And we're gonna do the same thing with beryllium and boron, and we're gonna slowly work through all those. So we'll see how many I get in this video. If not, I'll keep continuing because I don't want these videos too long. Also, haven't figured out how to post one over 15 minutes. So for lithium, we're looking to see if Li2 is possible. So that means I'm gonna have two different lithium's bonding, and we of course need to pay attention to our valence electrons. So lithium's electron configuration is 1s2, 2s1. I only care about my valence electrons, so I only care about that 2s1 molecule right there. And so I'm gonna have a lithium A and a lithium B, and they're gonna be bonding. I already drew my energy diagram. I dropped my eraser. I already drew my energy diagram, and so as you can see, I have these, which would be where the electron in its atomic orbital would be before it bonded. So we have one in each because I have the same element, so I have a 2s1 in each of them. And then we have our sigma, our 2 sigma s, which would be our bonding orbital. And then we have our 2 sigma s star, which is representative of our anti-bonding orbital. So these two guys are gonna fill up the lowest energy level first, so they're gonna go down here. And so this looks very similar to hydrogen, as we would expect, because it's in the same family, so we expect it to react similarly. So in fact, lithium would exist, and we can calculate the bond order by taking the bonded electrons, which would be 2, minus the anti-bonded, which would be 0, all divided by 2, and so that makes a bond order of 1. So that's how we would solve for lithium. And so yes, the answer is this could exist, and one of the videos I watched said that they Googled it, and it does exist. And that it exists, I'm picking up my eraser, that it exists with lithium, and it's actually at equilibrium with just Li, and then it goes back and forth between Li and Li2. So now we're gonna do it with beryllium, because next in your notes it says, yes, it may also exist. What is the bond order? We solved that, and then underneath it says, can Be2 exist? Which we will go ahead and solve for. So remember, when we're doing this, we need to first focus on our valence electrons, and so beryllium has electron configuration of 1s2, 2s2, 1s2, 2s2, which means we're focusing on this 2s2, so each of them start out with 2. Now then, whenever we're doing this, again, they're gonna fill up lowest energy levels first, and so they're gonna fill up this one first, so I'm gonna use 2, and they're gonna go to a lower energy level, which is good for them. But then 2 of them are gonna go to a higher energy level. And so when I do this, I take my bonding minus my anti-bonding all over 2. And so that's gonna be 0, which means that this one doesn't exist. And so then we're gonna move on to boron. So now we're just adding 1 electron each time to slowly show you how things are progressing. So we went from doing 1s1, so then we did 1s2, then we did 2s1, then we did 2s2, so now we're gonna do 2s2, 2p1, which would be boron. So in your notes, it tells you the general energy level sequencing, and so you need to pay attention. We are going in this order. If you look, hydrogen only had this guy, hydrogen, and then helium went here, and then whenever we did beryllium, or lithium, we were here, and then beryllium we got to here. So now boron, we're entering into this phase of where we're at. And so it's important to kind of understand what we're doing. I think the concept is a lot more important than, the AP exam isn't gonna make you draw these energy diagrams, but it's important to kind of understand where the electrons, the molecules, how they're forming, and the energy levels they're occupying. So we have boron, and I'm at 4.5 minutes. We'll finish page 8, and then we'll do boron on the next page, because technically it carries on to page 9. So whenever we talk about these things, we are still following Hund's rule, Pauli exclusion principle, and we're following Aufbau's principle. So let's remember all of these. So Hund's rule is saying that everybody gets their own room. And so you're gonna see that in boron. I'm gonna put one guy in the 2py or 2px and then one in the 2py before I go back and double up because they want their own room. Also, my arrows are gonna go up and down if they're in the same area because of Pauli exclusion principle saying that electrons occupying the same orbital spin in opposite directions. And then off-bow principle is saying they fill lowest energy levels first, which is why we start at the bottom and work our way up to the top. We wanna start at the lowest energy level first. Whenever you have two P's, if you have two X's and they go head to head, you have your anti-bonding and your bonding, they're gonna form a sigma bond. If you look at your anti-bonding, the Y ones, they are going to wrap around and form those pi bonds. So hopefully we can kind of see where we're going with all of this. Again, it's concepts, don't stress yourself out, okay?